Welcome back to the part 3, the last part, the writing part. There are 3 questions in this, but all of them carry total of 20 marks. And there are 2 more bonus questions in writing, which is 5 marks each. So they carry 10 marks. Total writing is of 30 marks. Please do practice them by writing. Don't just look into the videos. Understand and then try solving problems by yourselves. That is how you will learn and remember for your exam. Now we will continue, but before I continue, I would like to request you all, if you find this channel useful, if you're watching my videos, please do subscribe to it. And I want to thank all those who have subscribed. I greatly appreciate it. It means a lot. Do subscribe, like, and share it among your friends. Now we will move to the 21st topic. Write the specified type of proof. 2-column proof given NP. See over here, they have given some stuff that is NP is equal to PM. NP and PL are congruent. Okay, this is, sorry, not congruent, perpendicular. It's 90 degree. If it's perpendicular, this is the sign, it's 90 degree. We need to prove these congruent. And look over here, they have mentioned SAS postulate. That means side, angle, side. Looking at this figure, I can easily tell that NP and PM are congruent. These two right angles are obviously congruent, and PL is congruent because of reflexive property. But we need to write in proper way. So first, let's write this statement. NP equals PM, and this given, all we do is given statement. This PL and NP are perpendicular. That means these angles are 90 degrees. Okay. From this NP equals PM, that means the line are congruent to each other. If this is phi, this is phi. That's what it means, equal to. That means these lines are congruent as well. Okay, that's the definition of congruency. Equal means the lines will be congruent. Then we have this angles, right? Since it's told perpendicular, then they are right angles. So here MPL and NPL are right angles. So perpendicular lines form right angles and they are congruent. If both are right angles, obviously they'll be congruent, isn't it? 90 degree, 90 degree. Then what else? PL is the same line for both the triangles. It's from the reflexive property. So now we have the side, this angle and side. So from SAS postulate, we can prove that the triangle NPL will be congruent. If you start from N, remember you must start from M over here, NPL. That's the answer. But it must be written in detail. The figure will tell you everything. So make sure first start with the given and then write the remaining parts. Look at the figure, write them as it is. If you're getting confused, just write NP and PM. Write it over there, just as it is, and make sure you put the angles and solve it up. So that's it. Make sure you mention this in the bracket, or you can do a column, say like this, 2 columns. Statement and reason, it's up to you. You can just write statement, reason, and then first, what is the reason? Say NP is congruent to NP. It's given. So that's the thing. Just whatever it is, you can do it. Similarly, now we have one more problem over here, 2-column proof. So statements and reasons. They have given a lot of things. Let's write it. AB equals CD. They have told it's equal. Then they have also told AB is parallel to CD. Okay. So now, if this is the thing, if it's parallel, always remember, we have done this before in part 2 as well. Whenever there is parallel stuff, the alternate interior angle theorem comes in picture. You can see BAD and CDA are congruent. Why? Because these are parallel, so these are interior angles. That's it. Next, AD and AD is the same because it's a reflexive property. It's the same, right? They're reflexive property. And over here they have mentioned AB and CD. It's given. They have told it's equal, so we can tell they are congruent because of the definition of congruent segments. So basically you have S side, angle, and again another side. That's a SAS postulate. So please, over here they have asked paragraph proof, but it's fine. You just write any one of it. Make sure you write it. That's the most important thing. Now over here it's the same thing, just that V is the midpoint of W and X. If that is the case, then these both are equal because from the midpoint theorem. That's it. And they have told even for this angle, sorry, this line and this line, it's the midpoint. That means this line is equal to these are all equal to each other, okay? And then there's vertical angles, just that, SAS. So you can see over here there is vertical angle theorem, midpoint theorem. That's more than enough to prove this side is equal to this side is equal to this side, and vertical angles prove that all this is a SAS postulate. Similarly, please do try these by yourselves. Most of the things are given over here. It's very simple. They have asked a flow chart, given, literally everything is given, and then just that over here, literally everything is given. See, PR is congruent to DE, PT is congruent to DF, and they have told R is congruent to E, and then T is congruent to F. And obviously all the angles will be equal then, because the third angle, if two angles are equal, the third angle must be equal. That's called third angles theorem. And then you have literally so many things, but you can tell SAS or all the see, the thing is, if all the angles are equal, that's not enough to make it congruent. It can make it similar. Length might differ, so two sides must be known, at least two sides. In this case, see, this side and this side is congruent. So whenever two sides are congruent, and then, okay, there's one more thing. I understand why now it is important. It's SAS. Remember, the side. The angle must be in between. Look at this. This is not enough. Angle is outside. This angle must be congruent. So it's very important to write the statement. Otherwise, it's not SAS postulate. So that is very crucial. So what happens? These two angles are given. So you tell this angle is congruent. Then you get SAS postulate. And similarly over here as well, they have given a lot of stuff. Make a two-column proof. Here, see now one more thing. If they tell bisection, see, BD is bisecting AC. Bisection means it is cutting into right. Over here you can see BD is bisecting, right? Now then that means it cuts into equal angles. Bisect, now if you have an angle over here, you bisect it, it makes into equal parts. Please remember that. So that is very important. Bisection will make equal angles. Over here in this case it's a straight line, so it will be right angles. And then you can look through this, see the statements, and look at the figure. It's very straightforward. Make sure you solve them by yourselves and then check for the answers, because they're pretty easy. And that's basically it for the 21st topic. Remember, it's SAS postulate. You must have side over here, side, and angle in between the two sides. That's it. So in the next video, we will continue with the next topic, that is topic number 22. The 22nd topic is on lines. It's about parallel lines, perpendicular lines on neither, based on the slopes. Now they have mentioned just example 1, that is only this example, the first example which I'm doing. But then I will also do perpendicular or neither just as extra. It will be example 2 and 3 of the same lesson. So now let's look into the problem directly. Determine whether line AB and CD are parallel, perpendicular or neither for these particular coordinates. Okay, and then graph each line to verify your answer. It is very important for you to draw a graph. Now the graph is not given. You won't be able to exactly draw the graph. If the graphing sheet is given, yes. Otherwise, just draw a random graph. See, 3, 1, 2, 3. And this is 6, 1, 2, 3, 4, 5, and 6. Somewhere over here, draw a point. That is the point A. What about B? It's -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, somewhere over here, and -2 is somewhere over here. 1, 2. Then I'm sorry, this is the just rough graph, okay? And then let's do this. I'm not drawing an accurate graph, and over here I'll tell you what exactly this means to verify in a while. Let's draw the C, That is 1, 2, 3, 4, 5, and 4 somewhere over here. Okay, and then we have 2 and 3, whereas 2 and 3 is somewhere over here. See, my graphs are not at all accurate, but if you draw something like this, you should join these graphs. It should be a little bit accurate, and if you join this graph like this, you will get two parallel lines. But mine are way out of proportion because you can see the difference, the dimensions, the units are not accurate, but you will get something like this. You'll get a brief idea. It might be parallel or neither. So I do not need to check for perpendicular, because perpendicular graphs would be something like this. They're not at all like that because they are on the same way. You understand, right? Because they're something like this and one more is like this. So it's neither or parallel. If you graph them accurately, see, it's something like this. This is what happens. Okay. Now then, what do we do? Okay, I realized what was my mistake. I took -2 over here, 9 and +2. That makes sense now. It'll be over here. This will be over here, and this is the correct graph. Okay, my bad. Don't make the mistake I just now did. Instead of +2, I took -2, which was wrong. So anyways, now after understanding that, still we need to prove them. How do we prove exactly? You need to write the slope formula and use the slope. Find the slope of the coordinates. Now from this graph, you know A and B are on the same line. D and C are on the same line. So A and B is together. C and D is together. So if you're finding the slope of, say, this line AB, you need to consider this as x1, y1, x2, y2. This is very important. Then again, x1, y1, x2, y2. This would be the next one. So what do? Substitute them. Substitute in the sense, put over here, y2 is 2. Over here, just substitute in the formula 2 minus y1 is 6 divided by -9 minus 3. Put it in the calculator, you'll get the answer, or you can just solve it manually. It's 1/3, 1 by 3. Now find the slope of the line C and D. Now same thing, that is 3 minus 4 divided by 2 minus 5. You will get the answer, -1 by -3. It's 1/3 again, positive 1/3. The slopes are same, and we must remember, if the slopes are same, they are parallel lines. That's it. So yes, these are parallel lines. That would be the answer. But you know, you're not selecting the answers. You have to write the answer. You need to do the steps. The rough graph, write the slope formula, use the slope, and then solve it up. This is the method. So this is the example one. That's it. But let's go to another type of problem, just to see more problems if it's perpendicular or neither. Now in this case, they have given you the question with the graph, where they have not given coordinates. See, for this they are given coordinates, parallel lines. Over here, even if they give coordinates, it's easy to graph. You will get something like this, and you will understand it's either perpendicular or neither. Now, same method, same thing. But since over here graphs are not there, you need to choose the points. Now over here graph coordinates are not there. You need to choose the points from the graph. Here R and S are on the same line. Take 2 points on the same line and use them as x1, y1, and another line T and U, same thing. Now let's use this. Use the slope formula, y2 minus y1 divided by x2 minus x1. Substitute x1, y1, x2, y2. Put it in the formula. 7 minus of -3 divided by 6 minus of -8. The answer is 5 by 7. Now TU, what's going to happen? 0 minus 6 divided by 0 minus of -4, -3 by 2. Okay, the slopes are not same because they are not parallel. It's fine. But what you have to do is, you need to multiply these two slopes, and if you get -1, it is perpendicular. Multiply them. The answer is -15 by 14. That's -1.07. Look, it's very, very close to 1, but it is not 1. Only if you get exactly -1. -1 point, it should not be any decimal. It should be just -1. If that is the case, then your lines would be perpendicular, but over here it is not the case. So that means this is neither. These are neither perpendicular nor parallel. So you need to do the slope over here. If they're not same, then you must check for perpendicular, multiply the slopes. If they're -1, it's perpendicular, but in this case, it's neither. That's the answer. Let's do one more last problem over here. Similar type. Figure is given. Over here, the coordinates are there. Choose the points. In the line EF, you have taken the points. E is the first x1, y1. F is x2, y2. And then for line DG, similarly take the points and now find the slopes using this slope formula. That is y2 minus y1 divided by x2 minus x1. Substitute and solve. Again, substitute and solve. You got the slope over here. But compare, is it the same slope? No, it should not be same as well. It cannot be same as well because their lines are close to perpendicular. It's either perpendicular or neither. Now let's multiply the slopes. Let's multiply the slopes. What do you get? They're reciprocal, negative reciprocal of each other. 7 cancels, 3 cancels. You're remaining with -1. Yes, these are perpendicular to each other because the product of the slopes are -1. And sorry, let me just go back. And the answer is the lines are perpendicular. But if you just look in the figure and write perpendicular, it's not enough. You need to write the slope, substitute the slope. See, this is very, very important. Substitute, find the slopes, multiply them. If they are same, it's over. But if they're not same, you need to multiply, check whether it's -1, and then write this. So this is how you solve the penultimate problem, that is the topic number 22. In the next video, we will reach the final topic for this exam, that is topic number 23. This is the final video of the end of term 3 explanation videos. It is the topic number 23, and it is again about proving. We have proved just a while ago SAS postulate congruency by writing. Now we are dealing with SSS congruency. Here, all the 3 sides must be equal. That's the only thing. We need to make 2-column proof, and it's given. See, all the 3 sides are given. They have told AB is congruent to XY, AC is congruent to XZ, and BC is congruent to YZ. Then we need to prove it. Yes, absolutely. Why? Because all of these are given, right? What are they given? They are given that the side are postulate. If all the 3 sides are postulate, then they are congruent. But just make sure when you're writing AB over here and this one over here, which one will it be? So from A to B, B will be having the 3rd side, so it will be X to Z. A is having single dash, over here XZ, ABC, XYZ. So this is very important on the way you write it, and this is not at all difficult. It's just writing. But now, what if it's a little difficult problem? This also again a very simple one. They have told these 2 sides are equal, given, and then we need to prove these 2 triangles are equal. Obviously, the TS side is a reflexive property. It's the same side, so that is side. Let's look over here. RS and UT are congruent. It's given. RT and US, that's also given. Now ST is congruent to ST or TS itself because it's reflexive property. From all the three sides, we can tell it's congruent because of SSS postulate. Now here 2-column proof. The thing is AB over here is congruent to CB, but they have told D is the midpoint of line AC. From midpoint theorem, we know that this and this line, see, this is already given. Since midpoint theorem tells us whenever there's a midpoint, the line is equally cut into halves. That means AD and DC are equal. And then DB is a reflexive property. So we can prove that ABD and CBD are congruent. So that needs to be written. AB and D, whatever is given first, write it. So right over here, AD and DC, that is definition of midpoint. From the midpoint theorem it's given. And then from reflexive property, we have BD equal. So all the three sides are equal. That means we have SSS postulate. Similarly, please do try the other ones. They are very, very straightforward. Over here, they have told V is the midpoint of RT. So RV and VT are equal, and VS is reflexive property. So please make sure you go through these. It's very, very straightforward and simple. Basically, you're proving everything by SSS postulate. Um, Now here as well, sorry, they have given R, Q, R, S, T, everything is given. Only the middle line is not given, but you know that TR must be equal to TR or RT because of reflexive property. It's the same line for both the triangles. Therefore, we can prove by SSS postulate. Similarly, over here as well, they have given all this stuff. See, everything is given. Only thing is like they're telling you AC is bisecting the line BD. Remember, when you bisect a line, the line is cut into half. So we know BC and CD are equal. So BA, this side, this one side, this one side, and the top side all are equal. So we can write postulate. So it's very straightforward problems. Please make sure you go through these, practice by yourself, understand. When you look at the figure itself, you can write it. So for writing, this is one of the easiest topics. Your two paragraph proofs, or proof problems. So these are very simple, but please do practice and then be thorough with them. So that's it. That's the end. I just want to wish you all the best, all of you dear students. And I hope your exam will be easy, and I hope these videos have been helpful to you. If you have found them helpful, please do subscribe to them. It would mean a lot to me, and it will really give me a lot of motivation to keep on continuing such videos. And please do practice, write and practice. Write in not only the writing part 1, part 2, and the part 3. Write and practice them, and be thorough with them. Revise them plenty of times. Wish you all the best, and I hope everyone gets great marks. Until then, I hope you all have a great time. All the best, guys.